Good morning, students. I will invite Deepashri ma'am to start the session.
Okay, am I audible?
Yes, ma'am.
Okay. So yesterday we started the calorimetry. And I told you that in the calorimetry there will be two subparts we will be learning. We already did this part at a constant volume and the temperature. Now in today's class we will be doing at a constant pressure and the temperature. And we know that at a constant pressure and the temperature, we use QP. That is the heat absorbed at a constant pressure and delta H. So let's start with today's class. Okay. In case you have any doubt from the last class, do you? Anyone, any doubts? Okay. So, at a constant pressure and the temperature. So generally, so this generally involves the solids and the liquids and are carried out at a constant pressure and the temperature in a open styrofoam cups. So it is for solids and the liquids, for solids and liquids, and it is also carried out. Previously, it was carried out in a bomb calorimeter, but here it is carried out in open styrofoam cups. Okay, this is enough for you to learn. So this is the thing for at a constant pressure and temperature. So now we will be start with another topic, which is calculation of Q, W, delta H, and delta U for different process. Okay, so this all we will be learning today. Okay, now if T and N, these two are constant, then delta T will be 0. If delta U is N CVM, then delta T will be 0. Delta H is equal to N CPM. Then delta T will be 0. So let me write, then I am explaining. This is the first form of the equation. Do you everyone know about this? Yesterday we learned about the first form of the equation, right? So this is generally the first form of the equation. Okay, wait. Excuse me. So in this equation, we will be learning to calculate about the isothermal process. So in the isothermal process, temperature T remains constant. Internal energy delta U is 0. Enthalpy delta H is also 0. Wait, I have not written this. It is for isothermal process. So what we know about the isothermal process? In the isothermal process, temperature is kept constant, delta H internal energy is kept 0, and the enthalpy H is 0. So from the first law of the thermodynamics, we can write delta U is equals to Q plus W, and Q is the equivalent to negative, and from here we can conclude that it's in delta U is equals to 0. So Q is equals to negative of work done. So what is the magnitude of the work? The magnitude of the work depends on whether the process is reversible or irreversible. For this is up to this, is this part clear? I told you that we will be learning about the calculation of these four terms for different process. And we started for the isothermal process. And we know for a isothermal process, temperature is constant. Delta U is 0 and delta H becomes also 0, which is the enthalpy change. If you get confused, if I write like this, just imagine like this. For isothermal process, we know temperature is kept constant. Temperature is kept constant. Second is delta H is equivalent to 0. Third is delta U is equivalent to 0. Why we can write like this? Can write like this because this is for an isothermal process. These are the conditions for the isothermal process. So according to first law of the thermodynamics, we can use this equation. And Q is equal to minus of W. Up to this part, is it clear to everyone?
Yes,
Up to this part, is it clear?
yes, ma'am.
Okay. So now I have written what I have written, Q is equals to minus of work. But we know magnitude of work. That magnitude of work. Magnitude of the work depends on the process. Whether it is reversible or it is irreversible. Okay. So, if the process is reversible, what is the work done? So, work done is given by minus nRT ln V2 by V1. Or work done is given by minus nRT ln P2 by P1 by P2. Just the opposite. Here V2 and here P1 will come. Here N is the number of moles, R is the gas constant, T is the temperature, V1, V2 are the initial and the final volumes, P1, P2 are the initial and the final volumes. Okay, so for reversible isothermal process, use either of these two formula. But if the process is irreversible, then work done will be given as minus P external V2 by V2 minus V1. So P external is the external pressure. See, for irreversible isothermal process, if they ask you to calculate the work done, use this formula. So if this pressure is not given to you in your exam, suppose this is not given to you, this external pressure, is not given, then find the pressure of the system, then the final pressure of the system is considered to be the external pressure. Remember this. If in your question P external is not given, then consider the final pressure to be P external. So for this, is this part clear? So these are the different formulas you can use to calculate the work done for the reversible isothermal process and the irreversible isothermal process. Is this part clear?
Yes, ma'am.
Done. So let's start a sum. Wait. Let's do a sum. 1 mole of an ideal gas is expanded isothermally at 300 Kelvin from 10 atmosphere to 1 atmosphere. Calculate QW, delta H, and delta V. So just start solving the question. Try for 1 minute, then I will do. Done. Okay. No one? See, what it has been told that we have to calculate the work done, heat transferred, enthalpy change, and the internal energy change for 1 mole of an ideal gas undergoing isothermal expansion. Keyword: isothermal expansion at 300 Kelvin under different conditions. So first condition is expansion is free. What does this mean? Expansion is free. So in free expansion, gas expands in volume, vacuum. Remember, in it. I'm not doing here. First, we are sorry. Everyone has copied the question in their copy.
Yes, ma'am.
Okay, so let's do one by one. First is free expansion. Free expansion means gas expands into a vacuum. Okay, free expansion means gas expands into a vacuum with no external pressure. Which can oppose the expansion. This is the literal meaning for free expansion. Okay. So work done here. For this case, work done becomes 0. Why? Because there is no external pressure. And we know that if that external pressure terms P external V2 minus V1. If P external becomes 0, the whole work done will be 0. Okay. Now, in the question, what it is being said? That 1 mole is expanded isothermally. Now, in the question, can you see an exchange of the heat? Can you see an exchange of the heat? No. Q will be 0. Remember. So, work done becomes 0. Is it part clear to everyone? Yes or no? How the work done is 0?
No, ma'am.
Yeah, this is the definition, and thus P external V2 minus V1, that P external becomes 0, so work done becomes 0. Now you can tell me, ma'am, why is Q equals to 0? Because according to the question says that it is an isothermal expansion. This is an isothermal expansion, but it has not been mentioned that this is a adiabatic process. So why you are writing Q is equal to 0? This question came in your mind, why I have written Q equals to 0? Remember, if a gas is expanding isothermally and this gas is an ideal gas, then this process is not only isothermal, but this process is adiabatic also. Okay, another important point, that free expansion on an ideal gas will be both isothermal and adiabatic. Is this part clear? That is the reason I have written Q equals to 0. Is this part clear or not?
Yes, ma'am.
And we know delta H is equals to 0. Delta internal H is also 0. Why? These are the conditions for isothermal process. And in question, it is already written that it is an isothermal process. So, for question number 1, everything will be 0. Is this part clear? Clear or not? This free expansion,
No, ma'am.
which part is not clear for you? See, in your question, they have asked you to calculate the these terms. Work done, heat exchange, enthalpy change, and the internal energy change. For an ideal gas, right? For an ideal gas, they have asked you to calculate this. 1 mole for an ideal gas. These are the keywords you need to find in your question. At certain temperature from this pressure to this pressure. Now they have asked you to calculate these terms under different condition. First is if the expansion is free. I told you that if it is being said in the question that a gas is expanding freely, it means that gas expands in a vacuum with no external pressure. We know that the formula for work done is minus P external V2 minus V1. I told you free expansion. Free expansion means no external pressure. So minus P external becomes 0. So V2 minus V1. So this work done becomes 0. Is this part clear why work done has become 0 here? Yes or no?
Yes, ma'am.
Okay. So this is the work done becoming 0. Now, I told you that there is a condition. If it in your question it is being said that the gas is expanding for an ideal gas. This is only the case for ideal gas. For a free expansion on an ideal gas, if this term is given in your question, then you can be sure that this is both isothermal process and also an adiabatic process. Okay, maybe free expansion of an ideal gas. They just gave you the question like free expansion of an ideal gas is occurring. What will be the values of this? So you have to remember that free expansion of an ideal gas means it is both isothermal process and an adiabatic process. And for the adiabatic process, Q is equivalent to 0. Okay. And for isothermal process, it is already mentioned in the question that this is an isothermal process. So for the isothermal process, delta H and delta U both are 0. So ultimately, we calculated the values of every terms here. Is this part clear now? If you are not revising, you won't be understanding this. What is a adiabatic process? These are the things we have done in a week before class. And this is the isothermal process condition. I have written in my notes also what are the conditions for isothermal process. What are the conditions for the adiabatic process. Yes, that the free expansion of the ideal gas means adiabatic process, that you don't know, that you have known just now, but these are the rest of the conditions that we have already covered. So is this part clear? Is the definition clear? So how you will solve this question? Is this part clear for the
Yes,
first
ma'am.
part?
Yes, ma'am.
Okay. So what is the second part of the question? For reversible expansion, right? This is the question. So just now I told you what is the formula for reversible expansion? Minus nRT ln V2 by V1. So this is the expression, right? For reversible expansion of the gases. So in reversible expansion, okay, in reversible expansion, the gas expands indefinitely. expands infinitely. Slowly against infinitely, but slowly against an opposing pressure. That is always less than the negative pressure. Than the gas pressure. Okay, so for reversible process, I told you we use this formula. And what does the reversible expansion mean? Reversible expansion means that the gas will expanding infinitely, but there will be an opposite pressure. Okay, so the gas is expanding, but there is a small small pressure which is opposing the system. So W is equals to minus 300 R. 300 is the temperature. Okay. So you will not understand this again. So question is copied? Yes or no?
Yes, ma'am.
Good. So what is the number of moles here? What is the number of mole here? Check the question and say.
1 mole, ma'am.
Yeah, 1 mole. What is the temperature?
300 Kelvin.
300. Okay. What is the volume, final volume? So it's minus 300 R ln 10. Is this part clear how to calculate the work done? Clear or not?
No, ma'am.
Anything you want to ask me that how, ma'am, you have written this or how, ma'am, you have written that? The value of R is equal to 8.314 joule per mole Kelvin. Okay. N is 1 mole, which is given. T is 300 kelvins, which is also provided to you. So how much this is? Calculate and tell. So something will be coming in joule. Okay, whatever it is coming, let it come. So is this part equal done? Now, heat transferred is equal to negative of work done. Yes or no? Heat transferred is equal to negative of work done.
Ma'am,
Yeah,
is it in or M in the front of V2 by V1?
it is ln log, not log, it is ln. V2
Okay.
by V1. In your calculator, you can see this. Okay. Now say for the next question, you can solve this question later on. So for Q, we know that Q is negative of work done. We have just done here. We just did the question here. Here. Q is equivalent to negative work done for isothermal process. Okay. So whatever work done you will be calculating, just whatever value you will be getting here. Suppose it comes as minus x. So it will be minus of minus x, it will be x. Is this part clear? How to calculate the heat transfer? Is this part clear? And according to the question, delta H and delta, this is an isothermal process. So delta H and delta U both will be 0. This is for because it is an isothermal process. Because it is an isothermal process. So is this part clear how to solve the question? Is this part clear?
Yes, ma'am.
Okay? Okay, good. Next says that if the process is irreversible. So irreversible expansion means against a constant external pressure, and the gas expands rapidly against a fixed pressure. So what does this gas expanding irreversible mean? In an irreversible expression or expansion, against a constant external pressure, the gas expands rapidly against a fixed pressure. Okay. So what done? I told you that for a irreversible isothermal process, what is the formula? P external V2 minus
V2
of
minus V1.
V1. P external is the external heat. So what is the P external given as? What is the P external given as? See the question and tell me. 1. Okay, now you forgot it again. Don't forget it. Don't forget it. Remember in the question I told you this thing that if your P external is not given, then consider the final pressure to be your P external. What is the final pressure? 1. So
G
this becomes the P external for this case. Don't use this P external here. This P external is for this question. This P external is not given. So I told you also that if in your question P external is not given, consider the final volume as the P external. So this becomes our P external. So what will be this? -1, right or wrong?
right, ma'am.
-1 atom V2 minus of V1. Now, we don't know the values of V2 and V1, right? But in your question, it is being said it is an ideal gas. This term is given, it is an ideal gas, right or not? Yes or no? So
Yes,
we can
ma'am.
use this formula. PV is equals to nRT. Remember, this formula can be used only for the ideal gas. So what is the volume? Volume is nRT by P. Now we have to calculate V1 and V2. We don't know this. So how we will calculate? So let's for V1. So what will be the value of V1? nRT by P1. And what will be the value of V2? nRT by
By P2.
P2. What is N? 1.
1.
R, just now I told you, 8.314. I will be doing 1. You have to calculate this. 8.314 joule per mole Kelvin into what is the temperature? 300 Kelvin. And what is the in pressure? 10 atmosphere. Okay. So our initial volume I have calculated. It will be like 24.94 liter. Similarly, this upper part will be same, but here you will be writing 1. Okay. Is this part clear?
Yes,
For
ma'am.
this, you will be writing 1 into 8.314 into 300 divided by 1. So that will give you something around 101.3 liters. Okay. So now you know the values of V2 and V1. What is V2? 101.3 minus 24.94. So now you can calculate liter. So whatever answer you will get. So it will, if you so you will be getting something in liter atom, right? Whatever you will be getting in liter atom. Now, if you want to convert this liter atom to joule, remember 1 liter atom is equivalent to 101.3 joules. Okay. So from there you can calculate it to joule also. So is this part clear to everyone? How to calculate the work done? How to calculate the values of V?
Yes, ma'am.
See, in this question, we are solving a lot of things. We are using a lot of concept. I am teaching you how to solve. Again, what is Q? Sorry. What is Q? So second part is calculation of Q. Q is minus of W because here we have learned that for an isothermal process, we can use this formula. Whatever value you are getting here, just do the negative and you will be getting the answer. Enthalpy change, that is delta H, and the total energy change will be 0. Why? Because it is an isothermal process. So is this part clear? Part C. Is this part clear, everyone? Clear or not?
Hmm.
Anyone, any doubt, you can ask me. Okay. So what is the fourth one? In the fourth one is easy. They have told you that to calculate the work done, and it is obviously an irreversible process. Now you can tell me, ma'am, how did you understand it is an irreversible process? Because an external pressure is already mentioned in your question. So minus V external is 0.58 atom, and V2 and V1 values you have already got. Okay, so something you will be getting in liter atom. Q will be again the negative of work done. Delta H, delta U will be 0 for isothermal process. So is this whole question and how to solve, is this part clear? So is this whole concept clear to you? This whole sum is actually very important because this whole sum like tells you a lot of things. Okay. So is this part clear?
Yes, ma'am.
Okay. Next, we will do another sum. Okay. Sorry. So 1 mole of an ideal gas is expanded from 10 liters to 20 atom, 50 liters, suppose, respectively. So calculate work done. Against 5 atmospheric pressure, and then against 2 atm. Second question, if expansion occurs in single stage. Okay, solve. Try and solve. Okay, no one? Okay, so what it has been given in your question, just tell me once. Ideal gas expanded from here. Here, it is not being mentioned that it is a isothermal process. And here, it is not mentioned that it is a free expansion, right? So the problem asks you to calculate the work done by the gas in two different scenarios. What is the case? Case A, the gas is expanded first against a pressure of 5 atmosphere and then against a pressure of 2 atmosphere. Okay. So what is okay. Let's in the first step, the gas expands from 10 liter to 50 liter against a pressure of 5 atmosphere. So what will be the work done? So at first, the gas expands from 10 liters to 50 liters, sorry, 50 liters against a pressure of 5 atm. So what will be the formula for work done? Is this part clear? So what will be this?
100 liters atoms, sir.
You can ask me, ma'am, why did you use this formula minus P V2 minus V1? Okay, this is same as minus P V2 minus V1. Same. We represent delta to not write this. Okay. So because here constant external pressure is given. If constant pressure is given, then you have to understand it is an irreversible process. Now, at first against 5 atmosphere and then against 2 atmosphere. Okay. So how to calculate that 2 atmosphere? Now, gas has done work. This is W1, okay, has done work against 2 atmospheric. So what is the work done?
ATL atom, ATM.
Yeah, maybe it is that. It's 2 ATM, 50 minus 10. So it's kind of minus 100. Okay. So what is the total work done?
Ma'am,
Yeah,
how it will be 100?
50 minus 10. Okay, sorry. Sorry. Okay, so total work done is W1 plus W2 minus 200 liter atom plus minus of 80 liter atoms. Whatever you are getting the answer that. Is this part clear? The first part of the question is clear to everyone?
Yes, ma'am.
Okay. Now in the second case, it has asked you to calculate it in a single stage. So in this scenario, the gas expands directly from 10 liter to 50 liter against a pressure of 2 atmosphere. Okay. In a single stage means gas expanded directly from 10 liters to 50 liters against external pressure and what I have written.
Ma'am, can you tell me why did you write 10 to 50?
Okay, it's 50 to 10, right?
Yeah, ma'am.
50 to 10. Whatever will be given in your question against the external pressure of 5 atm. Not 5, 2 atm. So initially in the last scenario, the gas was against 5 atm, then it was 2 atm. But here the gas is expanding directly by 2 atm. Okay. So what will be
Ma'am,
the work done?
ma'am,
Yeah.
in the question we have 10 ATM, comma 10 L is expanded to 20 80.
Doesn't matter. That whatever it is written in the question, write that. Okay. I'm just trying to explain that this is the most neglected thing here. You are asked to calculate the gas expansion directly. I'm asking you that it is 100 liter to 10 liter, whatever it is given. This process will be same. Whatever given in the question, write that here, okay? And I am trying to explain you that what is given to you, that what is actually asked you to do. So what was the question here? That expansion from 10 liter to 50 liters. So yes, 10 liters to 50 liters. Ignore the atmosphere pressures. Okay. So this was the question, that 1 mole of an ideal gas is expanded from 10 atom 10 liter to 2 atom 50 liter. Atoms are not necessary. Whatever the pressure is given to you and the volume is given to you, that is necessary here. I have, like, very intentionally, I have given you these terms in your question so that you get confused. That why is this term given? This is the most useless term here. These terms will be given to you, useless terms, because these terms will be given to you just to make your concept clear, that are you using these atmospheric pressures or not? Doesn't matter. This is the initial condition. This is the final. Now, why they are useless? This is the initial state of the gas. This is the final state of the gas. When a gas moves from here to here in this direction, we are more concerned about the external pressure that influences this gas, not the pressure here or not the pressure here. For these two states, we just are bothered about the volumes. Is this part clear? Why we are not considering this 10 atom and the 20 atom in consideration? We are, for the initial and the final states, we consider the volumes. And pressure is like nothing. Even if they have not given the pressure, we will be solving this question in the same manner. We are more bothered about the external pressure. Is this part clear? Is this part clear?
Yes, ma'am.
Okay. So the boy who was asking me, is this part clear? Or yet you have a doubt?
Yes, ma'am.
Okay. So now, in the second stage, they have asked you that the gas has expanded directly from whatever, 10 liters to 50 liters against a constant pressure. Single stage means, at first they were saying that 5 atmospheric pressure and it was 2 atmospheric pressure. Single stage means this final turn. If here it was 2, here it was 5, then here I would have written 5 here. Okay, is this part clear? So
Yes,
it
ma'am.
will be minus 80 liter atom. If you want to convert it to joule, so it will be minus 80 into 101.325 something joule. Okay, so this is the calculation for the work done. Is this part clear? These two sums are very important. If you have understood these two sums, you will be solving all the sums in your textbook. Is this part clear? Whatever sums we have done today. This sum and this sum. Is this part clear? The whole of the sum and this sum. These two sums are very important because these two sums involve a lot of concepts. So is this part clear? Tomorrow we will be doing with the isobaric process and the isoporic process, then the adiabatic process. So is this part clear?
Yes, ma'am.
Yes, ma'am.
No doubts, I guess. Okay. Okay then. Okay then. So let's end today's class. Again, I will be meeting you on Thursday. Till then, practice whatever I have given you. Tomorrow, Himanshu sir will be taking the classes. Ma'am, that was from my part. Ma'am, okay, students, start joining the next session also. You have a class, right? Maybe ma'am can't hear me, is not or not present. Start joining the next class.
Are done with the class?
Yes, ma'am.
Okay. Students